adding and subtracting fractions. We'll use exactly the same method to add or subtract two fractions, and this time we'll work on fractions with different denominators. So let's have a look at this example. So the denominators are the numbers on the bottom, and we're talking about a quarter plus 2/3. So we cannot add quarters. Quarters would be something that size, 1 out of 4, and trying to draw the same one here. Oops, we need thirds this time, so roughly like that. 2/3 will be that size. But the important thing is to compare a quarter to a third. They are different sizes. Which one is bigger? The third. So we cannot say we can simply add one of these with two of those, because they are not exactly the same size. So what we have to do is try and find what we call a common denominator, a common bottom number. And of course we want to use the lowest as possible, because we don't want to do calcs with larger numbers. To find this lowest common denominator or bottom number, one method would be to list the multiples of 4 in this case, or the family of 4, or the times table of 4. So 4, 8, 12, 16, 20, 24, and so on. Then we list the family of 3. 3, 6, 9. These are the multiples of 3, or the numbers in the times table of 3. 3, 6, 9, 12, 15, 18, and so on. So what we do now is we look at both lists and check which numbers are repeating there. So the first pair of numbers that repeats is the 12. And then maybe if we had gone a little bit further here, we would have had 21, 24. We would have another pair repeating. So these numbers 12 and 24 are common denominators we could use for this calculation, but we will stick with the lowest common denominator. So what do we do at this stage? Well, we have to rescale each of the fractions. So we'll start with the 4. How are we going to turn this 4 into a 12? We have to increase it, so we'll multiply it. We'll say we'll times it by, some people even count 1, 2, 3, because 4 3s are 12, so multiply by 3. As soon as we do that, we have to do exactly the same to the top, because we must maintain the proportion here. Now we are going to have 1 times 3 is 3, 4 times 3 is 12, as we wanted. Do exactly the same to the other number now. What do we multiply 3 by to get the same 12? So we can count again if we want. 1, 2, 3, 4. Because 4 3s are 12, so the 3 must be multiplied by 4. We are rescaling this fraction now. The top must be also multiplied by 4 to increase proportionally. So we have 2 4s will be 8 and 3 4s will be 12. What's happening now? Both bottom numbers or denominators are matching. We are talking about size 12. If I could draw nicely here, I would have 12 equal parts, pretending they were exactly the same size. So this time we are talking in 12ths, so 3 12ths would be that, and then 8 12ths would be that. So we are talking the same size. We can add them this time. So we have 3 and 8, which we can say here 3 and 8. We have 11 of those 12ths. So basically, once the denominators are matching, all we have to do is stick with that number, stick with that size of fraction, and add the number of parts that we are actually talking about. So 3 and 8, 11. This method will be good for subtraction as well.